So, what happens when you take our newest, most powerful tool, AI, and point it at one of our oldest, most fundamental challenges? How to choose a winner? Well, we're about to find out how artificial intelligence is uncovering some really surprising truths about the systems we use to vote. And this really is the big question, isn't it? Can a neural network, a piece of code, actually get a handle on the deeply human, sometimes messy process of making a group decision? It's a fascinating question, sitting right at the crossroads of computer science and political philosophy. To get an answer, researchers are using machine learning to take a fresh look at a field called social choice theory. Now, this is basically the formal study of voting, and for the very first time, we're getting to see what happens when a machine, and not just a person with a PhD, tries to figure it all out. So let's break that down. What is social choice theory? At its heart, it's just the science of how we mash together a bunch of individual opinions to get a single group decision. Think about it. Every time you go to the polls, you're a participant in a giant, real-world social choice experiment. For the longest time, we've really only had one way of looking at voting rules, through the super precise lens of math and logic. But this new research is asking a really cool question. What if there's another way to do it? A method that might just show us some hidden truths about the systems we rely on every day. To really get what's going on here, we're going to use this fantastic analogy from the research. Imagine you want to understand a building. You could get the architect's blueprints and study every single detail. Or you could just get a bunch of photos of the building and try to figure out how it was put together from those. And here they are, side by side. The traditional approach, the axiomatic method. That's like studying the blueprint. It's formal, it's exact. The new way, with machine learning, is like giving an AI a big stock of photos and saying, all right, you figure out how this thing was built. So let's dig into the blueprint first. The axiomatic method is all about being precise. It uses formal math to define a voting rule by its core principles, its axioms. It tells you exactly how a system is supposed to work, in a perfect world, on paper. Okay, and now for the photos. The machine learning way is totally different. Instead of feeding the AI the rules, you just give it thousands and thousands of examples, election results. The AI's job is to work backward, to reverse engineer the rule. And the key thing we're measuring here isn't how elegant it is in theory, but something called learnability. Basically, how fast can the AI pick up the pattern? So with this new tool in their back pocket, the researchers set up a little competition. They picked 3 classic voting rules and basically challenged their AI to learn each one from scratch. Let's meet the contenders. First up, we've got the one most of us know best, the plurality rule. It's simple. It's winner take all. The candidate who gets the most #1 votes wins. End of story. Our second contender is the Condorcet rule. This one is a bit more like a tournament. A Condorcet winner is the one candidate who, if you put them in a head-to-head matchup against every other candidate, would win every single time. And last but not least, we have the Borda rule. This system asks for a bit more info from you. You don't just pick your favorite, you rank all the candidates. You get points based on where you rank them, and whoever has the most points at the end wins. All right, so you've got 3 different rules, one really smart AI. The big question is, which blueprint was the easiest to rebuild just by looking at the photos? Well, the answer was definitely not what you might guess. The results were pretty incredible. The AI found the Borda rule way, way easier to learn. I mean, plurality was kind of learnable, and Condorcet turned out to be really tough for the AI to grasp. But Borda, its learnability score was just off the charts. And the researchers put it really simply. When the AI was just trained on examples and had to come up with its own logic for picking a winner, that logic, it ended up looking a whole lot like the Borda rule. But here's the absolute wildest part. Even when the AI was fed examples from the plurality or Condorcet rules, its own internal model still kind of drifted towards Borda's structure. It's almost like Borda has this fundamental simplicity that the AI was naturally drawn to. So what on earth does this all mean, right? Why should we care if a voting rule is easy for an AI to learn? This is where we get to the real heart of this whole experiment. I mean, doesn't AI's learning curve really have any significance for us humans and the way we design our systems? And the answer is a huge yes. High learnability is a big clue. It points to a kind of hidden simplicity and regularity in a rule structure. It means the connection between the votes going in and the winner coming out is just more consistent, more straightforward. Learnability is basically a brand new way to measure design elegance. So let's just trace the logic here. Step 1. The AI finds the Borda rule is the easiest to learn from examples. Step 2. From that, we can infer that Borda's basic structure must be simpler and more regular. And step 3. The conclusion. This means learnability is a powerful new tool we can use to analyze our social systems. I mean, just think about that for a second. The AI wasn't just memorizing answers. By trying to rebuild the building from photos, it accidentally revealed a deep truth about the elegance of the building's blueprint, a blueprint it had never even laid eyes on. And this leaves us with a really provocative final question. We started this whole thing talking about voting, but the potential here is so much bigger. If this approach can find hidden patterns and simplicity in how we vote, what other complex human rules, in our laws, in our economies, maybe even in our ethics, is it ready to learn about next?